Good morning, good afternoon, everyone. I'm Umeri Dane from the Enterprise Data Governance team here in Credit Suisse, accompanied by a few of my staff members as well. Thank you, everyone, for joining the Risk Ontology FIBO demo that we have scheduled as part of our discussion for May 2nd. And as a refresher from the last meeting, or to those who were not able to attend the meeting on May 2nd, the objective of that meeting was to discuss the challenges and opportunities that are associated with the BCBS 239 adoption, and how we collaboratively can build an ontology that can help address the regulatory challenges that our industry is currently facing. From that meeting, we gathered different perspectives across our banking partners on this challenge, and we also understood that there are varying levels of knowledge related to ontology, and this is something that we wanted to address. And as a result, we arranged this session in order to highlight the FIBO capabilities and to demystify it by illustrating an example that would help bridge the understanding of risk ontology that is anticipated to be developed. So in just a moment, I'll hand it over to David Newman. He is from the Innovation Group at Wells Fargo and has kindly agreed to present these concepts to us. After Dave's presentation, we will discuss the next steps in our journey and end with any questions you may have. So before I continue, Mike Atkin, is there anything else you would like to add?
No, I'm good, Umar. Thank you for getting us started, and let's get underway.
Great. On to you, David.
Okay, thank you, Mayor and Mike, and good morning, everyone. Thank you for joining. I'm David Newman from Wells Fargo, and what I'm going to do is fill you up with a lot of information about FIBO. And what we're going to cover in this hour is the tip of the iceberg of the art of the possible with FIBO and of FIBO capabilities. So to kick this off, I want to show you a very brief demo of FIBO, and hopefully everyone can see my screen. So what this demo represents is FIBO operationally in action, where we are using one of our prototype derivative ontologies so that we could identify interest rate swaps from inputs coming in different formats. And let me just ask folks that are joining the call if you could kindly place your phones on mute. That would help everyone. Thank you. So what we've done is we've captured interest rate swap information, and what we've used FIBO for is to capture it into the FIBO ontology, validate it, and classify the inputs so that we could identify what type of swaps these are. So actually, these could be interest rate swaps, these could be credit default swaps. So very quickly, what we've been able to do then is generate certain analytics that identify from the set of swaps that we've captured right now, positions by countries. So we can look at this in many different perspectives. So we could see aggregation is done very effectively using FIBO, where we could say aggregate positions by swap instrument class. We have a very rich taxonomy that I'll get into a little later that makes aggregation very easy. It doesn't require often the complexity using conventional technologies because FIBO has an ontology, a very rich taxonomy. So this next query, this just went against a semantic graph database. We're using a Allegro graph for this test. And what it's showing is a set of counterparties in a derivatives trading network where we can use the properties of FIBO to demonstrate and look at the total aggregate position of each of these different organizations that are swap trading partners. The size of the icon is directly proportionate to the total positions. So you could see the larger the icon, the larger the position, and vice versa. Likewise, with these edges or lines represent basically the positions between each of the counterparties, and we could then dynamically alter the width of these edges that represent his trading with relationships to reflect actually the positions. And then we've run graph analytics using the semantic graph database. And it's important to know that when you're looking at problems or challenges that have to do with networks or graphs, you want to use a data structure that is already a network or a graph, which FIBO is essentially a graph structure. And so you can see these numbers represent eigenvectors, which are measures of centrality in a network. So Wall Street Bank has the highest, it's a 1, while some of the others, Atlas Bank is much smaller, California Bank is much smaller. And what these mean are, this is essentially directly proportional to the influence or the number of trading partners who have trading partners. So it's a measure of risk. So if Wall Street Bank fails, there's a greater cascading or transitive risk across the trading network than, let's say, if Atlas Bank failed. You can also look at ownership and control relations between different entities, and we can capture the meaning within FIBO of what majority owns and controls is and how that's different from significantly owns and controls or wholly owned controls. And then you could superimpose these two graphs together. So you could see all of the different trading partners with the lighter gray lines, and you could look at the ownership and control hierarchies with the darker red lines, and now you have more of a multidimensional view of the counterparties and their parent companies and or subsidiaries, and you can get more of a holistic view of risk across this whole spectrum. So I just wanted to give you a small snippet of what FIBO can be applied operationally as a demo. Given the time that we have, I have other examples, but I'd like to get to the actual presentation, and we can take questions a little later if there is time. So what I'm going to cover is, and what the data challenges we face in the financial system, how can FIBO be operationally applied today, how it could be applied in the future, and also how does FIBO work with artificial intelligence, and how does it position ourselves for innovation in the future. So let me take a step back and put this into a very, very broad perspective, and let's look at a chart of history of how we have fabricated physical things. So on this chart, we are looking at manual fabrication up to autonomous fabrication through robotics. And we go all the way back to primitive ages, and we've created things, tools, that we would call, let's call this monolithic. It's a single thing. And we could say this has a point in economic value from a logarithmic perspective. And it took millions of years to come to, let's say, around circa 1300, where we started to have a lot of evidence of creating machinery that's handcrafted and basically bespoke custom parts. Everything was unique, but we've moved up now to having, on a logarithmic scale, orders of magnitude economic value, because we've moved from one monolithic thing to machinery with many different parts that work together, although reminding you, these are all custom-built, bespoke parts. Now we jump forward into the 1850s, where we now have the benefit of mass production, and that comes about because we've developed the notion of standardization and reusability. That allowed us to drive mass production and scalability, where we had another leap of economic value in a logarithmic scale. And we jump forward again from into the 1960s to now and into the future, where we have autonomous, robotic-driven production. We'll call it hyperscalability, where we have machine intelligence driving standardized reusable parts again, where now we have a significant leap, again, logarithmically, of economic value. So let's use that as a backdrop where we can look at where are we today in IT and finance in relation to now fabricating data structures instead of physical parts and machinery. Again, the same scale of manual fabrication to autonomous fabrication. And we can look at the 1960s where we started off with mainframes and basic monolithic structures again, physical data structures, single flat files, where we had, let's say, that's our starting point of economic value. And then in the 1970s, all the way up today, we've developed the relational model, where we have also significant economic value, orders of magnitude economic value from a logarithmic scale. But also, the relational model, I have to say, is the equivalent of bespoke custom parts. Our relational systems are uniquely fabricated, typically for applications. Occasionally at enterprise levels, we have greater reusability, but mostly we have many, many localized relational models, which results in thousands and hundreds of thousands of columns of data that are highly bespoke, highly customized, and that is the prevailing method today. So now we jump to 2004 with the advent of semantic technology, which FIBO is based upon, and semantic technology enables us to have standardization and reusability. So as we looked at that leap we took in fabrication of things, we can begin to leverage semantic technology to fabricate data structures because of the unique capabilities of semantic that I'll explain and a little later as we go into this presentation. But this is a significant leap again, potentially for the future of economic value. And then as we reuse standardized reusable parts for fabrication of using autonomous means of things, we're also at the very precipice of leveraging reusable parts, reusable concepts based on ontology to now merge with AI, where we can have, again, hyperscalable capabilities, leveraging those standardized reusable parts or concepts for another future leap of economic value. So this is what we have in front of us. So the challenge is, how do we get from here, the relational model, all the way forward to pass through semantic technology, ultimately into the future? How do we leverage and apply semantic capabilities utilizing FIBO? And how do we then move forward into the future leveraging machine intelligence? These are challenges in front of us. FIBO is a pathway for us to get. It is the way for the financial industry to achieve economic value in logarithmic scale. So the challenge now. The financial system is a major, massive global network of interdependent entities, instruments, financial processes, data, transactions. It is one massive network. This creates tremendous challenges, though, for us, and especially for regulatory authorities to link, integrate, and analyze the data. But when we look at these financial processes that we're involved in across the financial industry, you can take loan origination and securitization as an example. You can see that this can be vertically partitioned into terms of standards that we already have today, such as MISMO and ISO 20022, FPML, FIX, etc. The challenge here is that even though we have many standards in finance, those standards themselves are often siloed and not interoperable. But our processes require interoperability in order to really identify the risk across these processes and ultimately to better support the customers. However, having these proprietary and siloed standards in many ways results also in a serious data incongruence problem. So what are the challenges that we face today in finance? Well, basically, we're not effectively solving our organizational data puzzles. We need to be able to better validate, curate, and classify data, reconcile and harmonize disparate data, link and aggregate data for risk management and analytics. Thus, a better data management capability is needed to ensure that data is aligned to common meaning, it's harmonized and integrated across all data sources, and it's understood not only by humans, but ultimately by machines as well. So if we look at our legacy environments, our conventional data management capabilities, we can see that we're really not solving these challenges in front of us as effectively as we really need to. And when we look at our current environments, we typically have a proprietary vendor that we use for a glossary to represent definitions. We may have another proprietary vendor where we develop our information models, our ERDs. And then, of course, we'll have one-to-many proprietary vendors where we have our databases physically and our schemas. And then we have more proprietary vendors to define rules or execute rules and to define metadata for all of the information that we're capturing. That is not a sustainable situation for efficiency and effectiveness, where we have multiple vendors that we have to fund. We have no common model across all of these different silos. We have limited expressivity using the relational model. We have to construct our physical objects after creating our logical and conceptual models, and these are often require long lead times to build, and they are not changeable very easily and therefore brittle. There is limited or mostly no reusability. And the other problem is that quite often we get out of sync between the actual data that's deployed and our glossaries, information models, and schemas and metadata. This is a major problem. We result in great redundancy. We have many, many labels for the same element. A credit card number could be spelled 20 different ways across the enterprise. It's highly labor intensive, and we end up having often data that's inappropriately assigned to a label or a column. So this is our current state, and it is not sustainable. So jumping into the future and how we move forward, what the next generation of financial data is, it is really based and should be based on semantic capabilities where we can maximize reusability. It's constructed and built to support reusability, and we must leverage that. But we have so many other benefits. We can represent concepts in ways that not only humans can understand, but machines can understand. That's a huge paradigm shift forward, where we have the ability to render the meaning of financial concepts in a very, very expressive way. That already is a significant differentiator, where we can use capabilities to validate the logical consistency of our model. We have the ability to link and integrate multiple ontologies or models into a broader integrated common model holistically, which is something that is another prerequisite for having this logarithmic benefit of economic value. It does not require a physical model. It is essentially virtual. It's easy to change and deploy, and a schema is not needed to load the data, so we could consume data very rapidly. And we have concepts that are linked and interrelated to other concepts, and we have metadata that's linked and interrelated to the ontology. We don't need a separate vendor platform to define metadata, where you will have the obvious breakdown and lack of consistency and integration, because it is all in the same model as opposed to what we have today. We can define knowledge representation and constraints. And the other bonus that I'll get into in a moment is we can leverage reasoning and inference to infer new relationships when we didn't see these relationships before. So based on these capabilities, the EDM Council said, we're going to make a commitment and an investment in leveraging semantic capabilities for creating a common language for the financial system following the financial crisis, where it became apparent that companies couldn't identify the risks of their own portfolios, and global regulators couldn't identify effectively the risks of the financial system because the data was highly opaque, because we've been building our data structures using a highly bespoke model, a way where we could not create a holistic view. FIBO is all about creating this holistic view. So as you can see here, we have certain business domains that we're building FIBO to support. Out of the box, initially, we have FIBO Foundations, which is basically a set of concepts and abstractions used for building FIBO that cut across all the different domains of FIBO. Essentially, it's even agnostic to finance, very broad-based. Then we have other foundational ontologies like business entities to define different legal forms and their ownership and control relationships. And then another foundational ontology, financial business and commerce. And then we started to build out our different domain ontologies around financial instruments, debt instruments, securities, equities, loans, and derivatives. So what essentially is an ontology? What does it look like? The basic meaning is that an ontology uses the notion of a triple. Triple subject, predicate, object. It's linguistically aligned with how we think and speak. It's a basic statement. It's the underlying fabric of how an ontology is defined, with a way where we can superimpose human concepts over an underlying logic that a machine can understand based on mathematical formulas and what's called description logic. So we can make a statement: a corporation controls another corporation, subject, predicate, object. We could weave in other concepts into this ontology. Controls majority voting shares is a kind of subset, a kind of controls, if you will. So we could say that if a corporation A controls majority voting shares of corporation B, corporation A controls corporation B. We can then weave in inverse concepts. Is majority controlled by is the polar opposite of controls majority voting shares. So we can say this has an inverse relationship. We could assert data into the ontology. Global Bank is a type of corporation, subject, predicate, object. London Bank is a type of corporation. And we could then assert that Global Bank, a type of corporation, controls majority voting shares of London Bank, a type of corporation. Therefore, we can draw an inference based on the rules of the ontology that London Bank is majority controlled by Global Bank, and Global Bank plays the role of a parent company. London Bank plays the role of a subsidiary. So through applying inference based on many of the semantic relations defined in the ontology, we can assert these new relationships that we didn't predefine before. And we can do all of this without one line of application code. It's all built into the ontology. So here's just a very narrow snippet of part of the FIBO ontology. Really, the mother of all concepts in FIBO is the contract. So FIBO is architected around the contract because financial instruments are kinds of written contracts, which are contracts. Contracts have various contractual elements. They have parties to the contract. They have contractual documents. We have financial instruments then that inherit the capabilities, the meaning, the semantics of written contracts, which inherit the semantics of contracts, which are also agreements, and so on and so forth. So we could narrow it all the way down to credit default swaps and interest rate swaps are kinds of swaps, which are derivative instruments, which are financial instruments. And all of these have relationships to many, many, many other objects and relationships. But this provides this conceptual scaffolding by which we can leverage some major, major benefits in being able to take a giant leap forward in identifying very complex relationships among data across different business processes. Without having an architecture like this, it becomes dramatically difficult to manage risk, to understand our customers. We have to have this kind of framework to take this leap forward in economic value. So as I talked about a little earlier, we have many siloed standards. FIBO is a way to unify these standards by creating this overarching layer of conceptual abstractions that can link and integrate the content of these other standards, not to replace them, but to unify and integrate them using a common language, and then the benefit of also providing the same framework to unify and integrate our line of business databases and our enterprise database and warehouses. So FIBO right now is published in many forms. The source of FIBO, the system of record, is in the web ontology language known as OWL. And from that, we can generate visual models of FIBO called Smith. We'll be generating FIBO vocabulary, which is a SCOS version of FIBO, which is a more coarse-grained representation of FIBO, still using a semantic language, but it allow us to ingest FIBO, for example, into data governance tools like Calibra and Smart Logic Semaphore and many others. We're also generating a text-based version of FIBO we call the FIBO glossary. And we also, I'll get into this a little later, are building a way of defining semantic tags over the web using schema.org based on FIBO. And then some point in the future, I would love to see us generate word embeddings from FIBO. What word embeddings are basically prerequisites for natural language processing and artificial intelligence, machine and deep learning, where we could then position FIBO as a basis to further accelerate machine learning in the financial system based on a common standard. It would need to be generated in what's called a neural word embedding, something we can do in the future. By the way, we will be publishing these through a website that we'll be making a major announcement on in a few days. So again, FIBO provides this conceptual scaffolding where we can have our enterprises import it, inherit from it, reuse it. So this is a small screenshot of an ontology editor tool we use called Protege, which here points out that we have in the ontology a publicly held company. It will have all of these different semantic attributes. It's organized in a jurisdiction. It has capacity for liability. It will have different labels. It'll have definitions. It'll have many other forms of metadata. And the publicly held company is a kind of stock corporation, which is a kind of corporation, and so on and so forth. So we can then import this. This is how we do reusability. This is how we position ourselves for mass production of data structures by having the import capability that semantic ontology provides. That is a huge differentiator. We can load FIBO's vocabulary using SCOS into different vendor products. This is a screenshot of loading FIBO into Smart Logic Semaphore, where we show as different bubbles, different concepts that are clickable to show relationships between contracts and other related attributes. We could load it into Calibra, and this is a screenshot from Calibra. And we can apply reasoning and inference. So this is a graphic rendition of a swap where we could use the semantic triples notation, which is part of a directed graph, where we could read it in a certain sequence, where we could say swap 1001 is a kind of swap which has leg swap leg 1, which has rate LIBOR, which has principal 10 million, which has currency. It has party, which is identified using a legal entity identifier, which identifies some business entity. So, and on the other end, we will have some similar data of the other leg of swap. So we provide a definition in FIBO of the swap. In this case, it's a fixed float interest rate swap, and we could provide a machine-facing definition in the language of the web ontology language, where we would say that an interest rate swap, rather a fixed float interest rate swap, is an interest rate swap that has a leg that is a fixed rate leg and one leg that is a floating rate leg. So we can then use a reasoner, again, a semantic capability that does reasoning over data, and it'll look at the objects and their relationships to other objects and draw an inference and classify this object. So swap leg 1, which is tied to LIBOR, can be inferred to be a floating rate leg, and swap leg 2, which is tied to a fixed rate value, is inferred to be a fixed rate leg. Therefore, following the definition of a fixed float IR swap, we could infer this to be exactly that, because one leg is fixed, one leg is floating. Alternatively, if we had two floating rate legs, we would infer it to be a float-float IR swap. So we let the data drive us to determine what it truly is. We don't attach a code to the data and trust that. We use the reasoner to look at the actual data to infer what it truly is. This is how we do better data curation, by providing this classification mechanism. And then it can further infer that a fixed float IR swap is an interest rate swap, which is a swap, which is a derivative, which is a financial instrument, which is a written contract, and so on and so forth. We can also draw linkages between other objects and infer that these business entities therefore must be trading with each other. So we could draw all of these new connections. It's essentially the equivalent of how the brain works, where we generate new neural connections based on other information that is available. So the key thing here is that we have a common model. In reality, data in our legacy environments are represented in many different ways. You can have the same business, meaning Global Bank owns more than 50% voting shares of London Bank, represented in text, which would be unstructured content. You could have the same business meaning represented in an Excel, in a relational database, in an XML message, in a big data name value pair. So what we can leverage FIBO for is to create this semantic harmonization layer to link and integrate information that exists across the many different lines of businesses within a company, or across many different financial institutions across the financial industry, and link and integrate into a common semantic model. Operationally, we have the capability where there are vendors that we've worked with, and I've done this operationally, where a particular vendor we engage applies machine learning to profile highly disparate data across many legacy data stores, and then using machine learning, identifying which elements are really the same across all these different tables, let's say, where it'll look at schema and actual data patterns, and then it will then draw an inference that these 20 elements are really the same, even though they may be spelled differently, like a credit card number or a social security number can have 10 or 20 different labels or tags. This aligns it together, and then it exports it into a form that can be loaded into a semantic graph database where we would have our enterprise ontology based on FIBO. So we can then link and integrate all these different, this technical metadata, if you will, into one place where we could ask the question across the enterprise, where are all instances of account numbers? Where are all instances of credit card number? Where are all instances of whatever it is that you have interest in? We can use this for sensitive data profile, look at where we have confidential or highly secure information. We can do this as a means to truly create a data lake. We could do this for better data inventory and analytics. And then for the real bonus, this is the pathway for strategic alignment and fulfillment of BCBS 239. Many companies apply conventional solutions at great cost for small, minimal, tactical fulfillments of BCBS 239. If you want to hit a grand slam and actually accelerate your strategic fulfillment of BCBS, this is how you do it. So we went through this slide. Yeah, I mentioned earlier schema.org. It's a way to have much more improved search engine optimization by having semantic tags associated with human-facing data on web pages so that machines can look at that hidden semantic tag, understand the meaning of the content that the human understands, and then capture it into a knowledge graph so that search engine optimization can be improved. And it positions us also for digital agents to query the web to perform functions such as obtaining the best possible home mortgage rates and criteria for a customer. This positions us to render retail products over the web for machine consumption. And let me just repeat, please put your phones on mute so that folks cannot hear background noise. Appreciate that. Thank you. So FIBO is collaborating with schema.org, which is Google, Bing, and Yahoo, to create the semantic tagging, and we'll be building out over time much more financial content that will be rendered by machines over the web. So how can FIBO be applied in the future? A couple of very, very cool capabilities emerging. One is coming, another one actually out of the W3C is called SHACL. It stands for Shapes Constraint Language. It's another semantic language. It's part of the evolving semantic capabilities where we can validate data. So we could define a set of constraint rules that we could define and link into FIBO that more specifically allows us to specify exactly how we want to validate data. Now, we could do this generally in FIBO now, but we could really do this more specifically as the SHACL capabilities are being released for operationalization. It's been approved as a candidate standard by the W3C, and we definitely plan on taking advantage of this. And the other beauty of it is that once it executes, it can explain the reason for an error. So if you have, let's say, a legal entity identifier that doesn't have the right format, for some reason a few characters dropped off, this would catch it. For any kind of data curation, data quality effort, this is a prerequisite. So this is something that we believe would be a natural next step for FIBO to support, to use these to validate concepts and to perform constraint rules for data. And this will be a big benefit. And it's a necessary next capability for FIBO. Now, this next one that I want to talk about is also another standard coming out of the W3C, the JSON-LD or linked data standard. So looking at message payloads, here's an example of an XML schema for an XML payload. This is specifically an FPML interest rate swap trade confirmation. What will happen with this? Well, this is not semantic, therefore it's not expressive. But what we can do is we can ingest this into FIBO and generate a payload using the new JSON-LD standard that transforms other formats and protocols into a semantic representation. JSON-LD is a message payload where the content is reflective of the ontology. So here is an interest rate swap trade confirmation message payload that exactly resembles the graphic representation of that interest rate swap that we covered a few moments ago. And moving it into a JSON-LD format now provides an alignment to the ontology rather than something that does not fully align with a financial industry common language. This sets the stage for creating APIs. APIs are now very big in finance. We can create APIs based on FIBO, so they now are standardized, and they can leverage certain new emerging capabilities, such as the Hydra standard, to allow highly dynamic APIs to be auto-generated. So with this, it now positions us to have full, complete, total alignment and standardization of data in motion and data at rest across the enterprise, across the financial industry. That's a big thing. That's a really big thing. It's so profound. It is really the way for having this order of magnitude economic value again. Without it, we're where we are, and we're going to have only problems if we don't stop kicking the can down the road. So this creates alignments in the enterprise. It creates alignments across the industry. It creates alignments with vendors. So vendor APIs using standard language, based on FIBO, makes interoperability with vendors easier. And then, of course, with regulators. Now regulators can see these alignments that can be done much more efficiently. So just quickly, this is a model architecture of how financial institutions can use some of these new technologies to layer a semantic harmonization layer in front of legacy systems. You don't have to change your legacy systems. We're working on a prototype with another vendor where it'll automatically translate XML into JSON-LD so that we can have automated semantic harmonization in an incrementally progressive way into the swap data repositories and in the regulators, the CFTC and others. So blockchain is another thing I'll just cover very briefly because I believe I'm running a little low on time, but by using this JSON-LD payload, we can leverage FIBO to essentially create a digital signature on these JSON-LD payloads by this creation of this FIBO API that could be a capability emerging in the future where a JSON-LD payload would be ingested into the FIBO API. We would then execute reasoning. We would execute the SHACL standard to validate the payload. and to perform classification. So this payload from the top is a swap contract. After we've run reasoning and validation, we could then regenerate the payload and say it's a fixed float interest rate swap contract, and we could digitally sign it that it has now been it has performed and has been successfully validated and classified through the FIBO API, and this then could be hashed and signed and basically anchored onto the blockchain. This is where blockchain becomes valuable. It's not, blockchain is not a prerequisite for this, but I took the liberty to show that this can be information externalized and anchored on a blockchain so that we can also make better use of some of the other emerging capabilities. Ethereum, which is essentially a virtual machine running on the blockchain that executes smart contracts. Now, again, because FIBO is built from the top down based on contract, FIBO is a natural for plugging a major hole that exists in the blockchain distributed ledger system today is the lack of standards. So it just seems, totally logical that FIBO would plug that gap, again, because it's already architected around the contract, and it could help to perform smart contracts, if you will, and ones that will have very easy regulatory audit. Speaking of regulatory audit, by having a common standard that is anchored on a blockchain, regulators can now, and well, not now, but in the future, will be able to automatically validate the integrity of information. In a sense, we wouldn't have to create reports. We would simply have to anchor the transactions on the blockchain, give the regulators the public keys, and the regulators could automatically iterate through the data, and we would have an automated FDIC living will, liquidity and capitalization reports without having to actually generate a report, send it to the regulators. The regulators can simply fetch it off of the blockchain. So how does FIBO work with artificial intelligence, with AI? Okay, artificial intelligence is several legs: knowledge, representation, and reasoning, which is really what FIBO is all about, and enterprise ontology. And then we have machine learning, we have deep learning, which is a kind of machine learning. We have natural language processing, which can only be better if it leverages machine and deep learning at a good corpus. What better corpus in finance is there? There is no better one than FIBO. And then all of these linked together can support cognitive computing. So ontologies can better enable AI. So moving up this stack of human-induced knowledge to machine-induced knowledge, again, we can see economic value moving from FIBO to an enterprise ontology to providing better foundational data for machine and deep learning, which can provide better data for cognitive computing. Again, FIBO can provide this conceptual scaffolding for validation, curation, linkage, and harmonization. The enterprise ontology will provide a means for a more effective supervised machine learning for various use cases for leveraging machine and deep learning. And then this will also provide a better foundational basis for cognitive computing. So I could spend a whole session on this, but just wanted to give you some high-level touch points. So that knowledge graph is another phrase we hear more and more. And knowledge graph really is the intersection of semantic graph with machine learning insight. So we deploy an operational semantic graph. We then can take that content, feed it into deep learning, and generate various probabilistic relationships and associations and classifications. And the intersection of that is a knowledge graph where we could ask questions like find all counterparties for interest rate swap trades that are likely, essentially greater than 99.5% to default given a certain percentage rise in LIBOR. this is how we do it. So specifically, this is a small graph. An entity is a customer, and we have the address, name, and other relationships. We have entity B, and those relationships. We can apply machine learning, for example, some basic cosine similarity algorithms to look at the data and identify perhaps that customer A is really the same as customer B, and link it together in a graph. So we can move in a way from highly disparate data to highly linked data. So also, FIBO driving enterprise ontologies could be used for enterprise knowledge graphs that could support chatbots and virtual assistants, where the information can be captured from a communication into a triples form. It could also then be used to iterate through a graph to return various answers. In this case, the customer is asking for a kind of product that would meet a specific set of needs, and an enterprise knowledge graph based on FIBO is certainly a way to do that. So with that, I'm going to stop and let me turn it over to Umair, and I'm going to jump over to some of his slides.
Okay, thank you so much, Dave. So given what we had set out to achieve from our May 2nd meeting, and based on today's discussion, covering the core concepts of ontology, FIBO, and the relevant capabilities, and just getting a better understanding of FIBO itself, let's talk about the next steps. So as I stated at the top of the call, our aim here is to work with all the banking partners and collaborate on building an ontology that's utilizing FIBO, leveraging the semantic capabilities, that's just going to help us address some of the challenges we are all facing as we go through the BCBS 239 adoption. We, as in Credit Suisse, are very interested and eager to move this initiative forward, and we have high interest from several banks thus far to collaborate and get this project underway. We are asking those banks who would like to take part in this development to identify the level of participation and provide the context from your organization that would take part in this process by July 14th, so 2 weeks from now. If there are specific preferences or regarding specific risk measures such as capital, liquidity, LCR, RWA, that a certain institution has an interest in, please let us know so that we can bring that under discussion. We are going to kick off a working group session that's going to be scheduled starting in early August to set the initiative in motion. The kickoff session is going to focus on things like setting the agenda to our future working groups, setting and agreeing on the objectives of the risk ontology build, which includes the life cycle. We'll discuss any project planning activities, etc. So therefore, it's very essential to provide your context as early as possible so that they and your institution don't miss a lot of the early planning stages. So with that, let me stop there and see if there's any questions from any of the participants.
Are you going to send out a template for the information that you want for this?
I'm sorry, could you repeat that?
Are you going to send out a template for the information that you want people to respond with?
Yeah.
Yes, we will collect. I understand. It's a good idea. We can do that.
Okay.
In these templates, can you define the levels of participation, please, so we know exactly what we're putting ourselves forward for?
Mm-hmm. Yep. Any other questions? So David, Umar, thank you very much for this. It was terrific. If you give me 1 minute, I'd like to extract upward a couple of simple points. So the semantic capability exists. FIBO is the semantic concepts for finance that exists. We're able to capture the model of things in a standard way using the web standards. David, you explained all of the value and things we can do that we can't do now. The process for collaboration exists. What's missing is the ability to capture collectively the model of risk concepts. So Umar, if I hear this correctly, that's what we're talking about, collectively modeling the risk concepts into this existing process.
Yep, that's correct, Mike.
So thank you all for your participation. We'll get this template ready. I know we've recorded this session. We'll put it up on our website and make it available. And let's call this meeting adjourned. So thank you very much.